Okay, alright, welcome to chapter 7. Okay, so chapter 7, okay, is about simple harmonic motion lah. Okay, so if you want to look into simple harmonic motion, okay, SHM, okay, so one simple motion is that, let's say if you have a pendulum, okay, and then you displace to the right, okay, so that means you will have a positive amplitude. Okay, and then as you release, what will happen is that the pendulum will swing and then make an oscillation lah. Okay, so now this information, what we can do is that you can put it in a graph. Okay, so you can have a displacement. Okay, so displacement versus time graph. Okay, so displacement versus time, so you start from equilibrium. Okay, so you displace toward your right, you will have positive amplitude. Okay, and then return back. Okay, so displacement will become 0, and then continue over here, that means you will have negative displacement lah. Okay, and then so on lah. Okay, so the information that we can obtain from here is that you can obtain the value of amplitude. Okay, so from here you can obtain the period. Okay, another graph, okay, is that you can have displacement versus distance. Okay, so since displacement, okay, you have a vector quantity, okay, distance will be a scalar quantity, so that means distance will always add up lah. Okay, so let's say it makes a swing. Okay, so distance will always add up. Okay, so the information you can get over here, okay, amplitude, and then from displacement distance you can obtain the value of wavelength over here. Okay, wavelength. Okay, so based on basic understanding, okay, so this one basically you will have a sinusoidal graph lah. Okay, okay, so over here we have a general equation. Okay, so for the general equation, okay, alright, so x will be equivalent to a sine omega t. Okay, a sine omega t, okay, plus phi if we have an initial phase lah. Okay, so this one will depend on the question lah. Okay, whether you have an initial phase or not lah. Okay, okay, so over here you have an equation given. Okay, SHM equation. So x varies with time. Okay, so that means the position will depends on time lah. Okay, so x is given in centimeter and t is in second. Okay, so they wanted to determine the amplitude. Okay, you can straight away obtain from the equation lah. Okay, which will be HCM. Okay, just compare lah. Okay, so if you compare, so this one over here we have x is equivalent to 8 sine, okay, 3 pi t plus pi over 2. Okay, so compare, a will be equivalent to 8 lah, this one over here. Okay, and then they wanted to determine the frequency, period and phase constant. Okay, okay, so the initial phase, this one will be the phase constant. Okay, so if you compare, omega will be equivalent to 3 pi, right? Okay, where omega, sorry, over here 3 pi, where omega will be equivalent to 2 pi f. Okay, so which is equivalent to 3 pi, so therefore frequency will be equivalent to 3 over 2 hertz lah. Okay, so frequency 3 over 2 hertz. Okay, you will end up with 1.5. So once you have frequency, you can determine the period lah. Okay, where period will be equivalent to 1 over f. Okay, okay, done with question A. Okay, B, velocity and acceleration. Okay, so in order to determine velocity and acceleration, so now let's say you have equation. Okay, x a sine omega t plus phi. Okay, so this one you have to relate with additional maths lah, okay, from your secondary school. Okay, where v will be equivalent to dx over dt. Okay, we differentiate lah, so that means d over dt a sine omega t plus phi. Okay, so we differentiate it's a function of time. Okay, so that means you will end up with, okay, so this omega, bring it out lah. Okay, so we'll end up with a omega. Sine will become as a function of cos, okay, omega t plus phi. Okay, so what you can do is that try to relate with this equation. Okay, rearrange in these terms. Okay, you will get the equation for v lah. Okay, that means for velocity. Okay, okay, so now we have velocity. Okay, cos. Okay, and then for acceleration. Okay, so acceleration will be equivalent to, okay, dv over dt. So that means you have to differentiate d over dt. Okay, a omega cos omega t plus phi. Okay, so differentiate same thing, okay, with t. So omega, you bring it outward, so you will end up with a omega square. Okay, cos, you will end up with negative sign. Okay, so in front you will have a negative value. Okay, and then omega t plus phi. Okay, so once we have the equation, okay, so you can try it out lah. Okay, okay, so now that we have the equation, okay, so try to replace, modify the equation. Okay, so the C, they wanted to determine the displacement, velocity and acceleration, right? Okay, for t, so just replace the value of t equivalent to 2, we have to calculate lah. Okay, for each value. Okay, and then maximum speed and maximum acceleration. Okay, so when we have maximum value, okay, so what will happen is that the function sine, okay, and then followed by the angle, it will end up with 1 lah. Okay, it doesn't matter lah, either you have sine or you have cos. Okay, so you will end up with a value of 1 lah. Okay, so 24. Okay, so over here, if you just multiply lah. Okay, so a omega, a is 8. Okay, 3 pi. So 8 times 3 pi, you will end up with 24 pi. Okay, okay, alright, so try to do it first. Okay, relate, and then good luck lah. Okay, try to relate lah. Okay, alright, that's all. Thank you for your attention.